Well, hello everybody. Welcome to part 3 of the Stewart Warner AM shortwave console radio restoration. And tonight, kill some time, I'm just testing some tubes. And out of the 10 tubes, I've found 3 that are very quirky, and this 27 being one of them. Some of these I've found, they'll jump right up into good range until they warm up fully. Then they almost flatline completely. Like this 27, when I plugged him in, was almost up to 70% emissions. It's dropping slowly. We're just about 52% in a week. And my first initial test with this particular tube wound up at 12% emissions. And going through the leakage section of this Superior 450 tube tester and running it through the ranges and stuff like that, does show a short up here on E and F. And I've also got a very weak 2A5 output tube that's showing about 16% emissions and a short on one of its internal conductors too. Other than that, every tube that's up here is good. I'm glad. A couple of the 58s, these two are Sylvanias, the bases are loose on them, and this RCA's just fine. But there's a mishmash of different tubes in this set, that's for sure. Let's see, now we're down to 36% emissions on this tube. It's still dropping. Here, this one tube should be a number 27. There's supposed to be two 27s in this set. This is a 56. Now, I haven't looked it up online, and I can't find it in my tube receiving manual, but it tests pretty decent. And I'm guessing the 56, like I said, without looking at it online, probably has about the same characteristics as a 27. But I'm going to check that out. Other than that, the only other one that acts very quirky, I think, was this guy right here, 35. Yeah. This is an RCA Cunningham tube, and 64% emissions, and it's kind of leaky on a couple of the tests. But for the most part, except for this one here, this 27 and this 2A5, almost all of them test about halfway up in the green. So that's a good thing to see right there. At least I don't have to go digging for too many tubes.
Well, hello there again. Like I said, this is part 3 of the Stewart Warner radio repair. Now, I showed you over in the first part of this video, I'm doing some tube testing tonight, and 8 of the 10 tubes actually check good on this set, which is great. You know, these things are kind of hard to come by. Some of the tubes are rather expensive, you can even find them. We got really lucky. I have one output tube, a 2A5, that's pretty much a flat line. This was a RCA Radiotron, and I noticed when I tested this one, the filament didn't glow quite as bright as the other output tube, and the other one tests up between 65 and 68% emissions, and that's good. The other two tubes that have me kind of befuddled a little bit are these two. This is a number 56 Raytheon. This is a number 27 General Electric. Well, the set calls for two 27s. You guys out there know more than what I do. Somebody jammed a 56 in here. These tubes basically are described as the same type of tube. And can the 56 actually be put in place with 27 and be correct? That's what I'm wondering. Does somebody just jam this in there not knowing what they did and 56 a proper replacement for a 27? I guess I should ask, because they aren't giving these things away. These are about $15 a piece for the two A5s, and the 27s are about $12 a piece. That's looking at vacuumtubes.net, their website. So, throw me a bone out there, everybody. See if you might be able to help me out a little bit on them. Maybe we can find some tubes a little cheaper. Other than that, all the rest of the tubes tested very good. Need to get my mug in the picture there if I did. Took my schematic tonight and lined everything out. Things that are in pink are capacitors. Things that are in green are resistors. Things that are in blue are either a coil or a transformer. Yellow are the shortwave switch, the tone switch, and the power switches. And things that are marked in orange are the tubes themselves. The 27 is used as an oscillator and a phase reverser tube. There's no mention of a 56 anywhere on there. So that's where we're at. Getting ready to start testing the coils and the transformers. Don't want to get the horse too far ahead of the cart and find out that this thing might have an open transformer or something like that. I have found a few repairs in here that are probably something to keep this set going. One of the main electrolytic capacitors, condensers as they're called, is an 8 microfarad on the top. It's a can electrolytic. Was replaced in 1970. It has a date code of 3/19/1970 on it. So they replaced that when the other one went bad, and they threw this little 10 microfarad jobby underneath of the chassis. So there's 2 replacements. Both of the electrolytics have been replaced at some point in this thing's life, sometime around 1970. This big resistor right here at the back of the set, it goes from here all the way down to here, has went bad, and they've tied 2 Utah 15,000 ohm resistors together to get the equivalent that this one resistor here delivered, which according to my schematic is let's see, 1950, just about 20,000 ohms. So because there's one section of this that delivers 200 ohms, there's one section of it that delivers 10,000 ohms, and there's one section that delivers 7,500 ohms. And these two 1500s are tied together and then bridged across this right here, this terminal right here, and this terminal right here. Other than that, I see very little replacements or any kind of work done in here. I was kind of torn whether to replace wiring in this radio, but I'll be honest with you, everything looks good. Nothing's burnt. This is the old cloth covered pushback style wire. The coating is not hard. I'll probably replace this wire here, the speaker output wire. It's kind of chewed up. It's got some nicks in it and the coating, but that just comes in here and ties into the output tubes and the power supply and all that good stuff. And of course the line cord, which comes in right here and right here, and that is a factory tape job. Interesting, the stuff you find in some of these sets. But that's the way it's supposed to be. The coils are also interesting in this particular radio. You can see them right here and here. Here's 2 more, here and here. They're open from the bottom, so there's not really no cans to pull apart per se. And then all your trimmers are here, 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 and I think that's it. Yeah, I think that's it. And then of course your oscillators right here. a very interesting design. It's got the old mica mold capacitors, low value capacitors in it. Most of the dog bones are original, if not they are original. And I'm thinking about doing something else to this set as I'm going through it, is actually pulling these capacitors and restuffing them. Well, not particularly that one, but these here, all these little value, smaller, tinier ones, thinking about restuffing them. And then possibly doing something with restuffing the cans on the top. Thinking about it right now. I've been thinking about this radio a lot the last few days, last week, Thursday and Friday, what I'm going to do to attack it. And there was a video put up by Banderson TV where he actually constructed his own dog bone resistors, and I got a note on the last Stewart Warner Part 2. Somebody told me that he did that too, so I'm going to go back and watch that video, and if they aren't too hard to build and I can get the supplies local, I'm going to take a stab at it, folks. I'm going to put a modern resistor inside of whatever he used, probably molding clay or something like that, and we're going to make some dog bone resistors for this set. I don't see any point to skimp on this thing. It's a, you know, it's 70 some years old, let's put it that way. 73, 74 years old probably, close to 75. And I don't see no reason to half-ass this thing. I want to do it right. And I know everybody has a different perception of what's right. I'm going to do it the way I think it should be done. And if I run into any snags or snafus along the way, I know who to ask. You know, there's the proper people out there that know what they're doing, and we'll get through that. But not everybody's way is the right way. Just remember that, and just do the best you can with what you have. More or less what I do. So I pulled the tubes out. The tube pins are going to get cleaned with alcohol and probably a piece of pipe cleaner. So I'll just run it down through there and tighten them up a little bit. I know some of them are loose. We'll probably rebuild this 1/8 microfarad capacitor electrolytic right here, which is another mica mold product. But first and foremost, let's get to testing this transformer, the audio output transformer, and testing the power transformer. This is very odd. Our primaries for this power transformer go in right here, and the secondaries and the filaments and everything else come out over here through the metal chassis. There's no rubber grommets there. It's kind of an odd design, but the wires look good. Nothing's frayed, nothing's chewed up, there's no signs of rodent poo in here anywhere. So I think we're going to be in good shape, and this is going to be a pretty easy set to work on, I hope. So I'll get to doing some testing here, and we'll get to work on this thing. Okay folks, here's what I've found so far. All of our coils test good in this radio. That's great. That's no problem at all. I do find a little bit of funkiness in this set, that the schematic says stuff should be there and it's not. Our primary in 110, 115 volts into our transformer is this particular wire right here, and then this one right here that comes off of our power switch. These are our mains input, 115 volts. Okay? We're not supposed to have but one ground on this side, and that is this, I'm assuming, the bypass capacitor or a noise capacitor or some kind that comes off of the power switch and goes directly to ground, which it shows that particular capacitor right here is number 31. Okay, so we got that one, but let me show you the schematic one more time. There's grounds that come out of the secondary side of this transformer, or the output side of the transformer I should say, which is this one here and this one here. Now there's more than one ground here. This brown wire is a ground, and these two black wires are ground. There's 3 grounds right there. Okay? Now, our schematic shows on the output side of the transformer into the radio 6 wires. These 2 go out to the 80 rectifier for the plates. These 2 go out to the 80 rectifier and down to our 8 microfarad electrolytic capacitor, our electrolytic capacitor. And then these 2 go out to filaments. That's 6 wires, right? 1, 2, 3, 4, 1, 2, 3, 5, 6. Okay? We've got 1, 2, 3, 4, 5 wires coming out of that transformer, and 3 grounds, where we should be having 3 wires, or 6 wires over here, right here, on that guy, and 1 ground coming out this side, which we've got 2. It is what it is, you know. That's obviously that way for a reason. Our output transformer tests A-OK. And I had to laugh the way they designed some of this stuff. Like, for instance, the capacitor for the tone switch comes down all along these wires right here behind the transformer. Here's our capacitor for our tone switch clear back here in the back. But I guess it has to be there because of the 2A5 output tube. It probably has to pull a tap off of that, I'm assuming. So it makes perfectly good sense where it's at, but it's just a very roundabout way of getting there. I did some testing on this big resistor back here, and I've come up with a couple different things that are the reason why these are patched in here. These 2 Utah 15,000 ohm resistors, they put them in there basically to cut them in half. They should be 750 because, or 7,500 ohms, which is what this thing wants to see. This bottom section right here, turn the meter around, maybe you might be able to see it, should be 200 ohms. Very good, that's what we want to see, that's okay. Now, let's test this big bridged mess up here. Like I said, this thing wants to see 7,500 ohms right here. And we test in at 7310. So that's okay. And this other one back in here, I mean, that's not okay. That's what it's supposed to be. I'm just trying to figure out what they got going on here. Now, this guy right here was the one I was in question with on the last part of the video. And it looks like a big fuse stuck in there. It's got like a solder end on either side. It's metal right here and here. And this jobby should be 10,000 ohms. That's what it'd be at here. Yeah, right there. Should be 10,000 ohms. For that range. And obviously it's a little out of tolerance, probably plus or minus 20%. Be 10,000 ohms, it's 886 ohms, so it's under what it should be. But I don't know how well. You guys can see that thing. Right there. whether y'all could see that or not. So, first step that we had to do was testing those transformers is good, so that's a great big thumbs up. That's good to know. It's going to need resistors. All the coils test good. So things look like they're a go for this particular radio. It's been given the green light to be restored, and that's awesome. So guys, that's part 3. I know I kind of mumbled around a little bit, testing some stuff. And I didn't really want to show it on camera because I'm still kind of green. This is my first radio with a transformer, and I kind of wanted to feel it out on my own and not make a fool of myself while I'm shooting the video. So that's where we're at right now. This is basically just an update video of things I've found, and I'm going to do a little bit more research over the next week, and hopefully by either next Friday or the weekend next week over the holiday, I'll be able to start to dig into this thing, and we can start replacing capacitors and figure out how to remake these dog bone resistors. It should be a fun project. Paint them up and dot them like they're all right now. And another major thing we got to do, somebody or something must have clipped the front of this set right across these controls. See how that potentiometer for the volume control is bent? That is a replacement too. That's a 5,000 or 500 ohm Mallory carbon trace switch. That's been replaced. And these two are original, but this tone switch is bent too. The band switch is not real bad. And the tuner knob, I bent it back just a little bit. So that's where we're at right now, guys. I didn't mean to ramble on and bore to death some people, but that's what's going on, and that's it for now. We'll see you in part 4. Thanks for watching.